Consider two processors P1 and P2 executing the same instruction set. Assume that under identical conditions for the same input, a program running on P2 takes 25% less time but incurs 20% more CPI as compared to the program running on P1. If the clock frequency of P1 is 1 GHz, what is the clock frequency of processor P2? We are having two processors P1 and P2. We are executing a program on the same instruction set under identical conditions and for the same input on the two processors P1 and P2. And it was observed that the program takes 25% less time on P2 than on T1. Means if the time taken for that program execution on processor P1 is T1, then the time taken for the program execution on P2 is T1 minus 25 by 100 into T1, which is 0.75 T1. Means we are executing the program faster on processor P2 than the processor P1. But it incurs 20% more CPI as compared to the program running on P1. On P2, the CPI is actually 20% more. Mean on P1, if CPI is equal to 1, then on P2, CPI is equal to 1 plus 20 by 100, 1.2. It means once the pipe is filled on both the processors, if we are processing one instruction out in one clock on processor P1, we are processing one instruction out in every 1.2 clock on processor P2. Since all the conditions are identical, the time taken to fill the pipe can be neglected. It means we are processing one instruction out in one clock in processor P1. At the same time, we are processing one instruction out in only 1.2 clock on processor P2. But even then, the entire program execution takes lesser time on P2 compared to that of P1. Then what should make that difference? The clock time period should be making the difference. On processor P2, the clock time period should be less. It means within a shorter time period, we are getting one instruction out on processor P2. That's why even though the CPI is higher, we can execute the same program faster on the processor P2. Now to find out the clock time period, on processor P1, the frequency is given as 1 GHz. Hence, the time period is equal to 1 by frequency, 1 by 10 power 9 seconds, which is equal to 10 power minus 9 seconds or 1 nanoseconds. The time period of each clock in processor P1 is 1 nanosecond. The time period of each clock in processor P2 we do not know. We need to calculate it. Let it be C2. So here in every 1 nanosecond time we are processing one instruction out, and here in every 1.2 into C2 time we are processing one instruction out, and C2 we need to calculate. Now how to connect both this? This is the time taken to process the entire program, and this is the time taken to process out one instruction. Suppose there are n number of instructions, then T1 is equal to n into C1. We are executing the same set of instructions on processor P2. The total time taken is 0.75 T1. Time taken to process one instruction is 1.2 C2. Hence, 0.75 T1 is equal to n into 1.2 C2. The number of instructions is same on both sides, hence we shall equate both this. So here n equals T1 by 1 nanosecond, and here n equals 0.75 T1 by 1.2 C2. Number of instructions is same, hence T1 by 1 nanoseconds is equal to 0.75 T1 by 1.2 into C2. So what is C2 then? 75 into 1 nano, 0.75 into 1 nanosecond divided by 1.2, which is equal to 0.625 nanoseconds. So we can see the time period, the clock time period for the processor P2 is lesser than the clock time period for the processor P1. Here we are processing one instruction out in 1.2 into 0.625 nanosecond, which is equal to 0.75 nanosecond. And here we are processing each instruction in 1 nanoseconds. And the question is what the clock frequency of processor P2. We know frequency equals 1 by time period. Hence the clock frequency F2 is equal to 1 by 0.625 nanosecond, which is equal to 1.6 gigahertz. So a lower clock period means a higher frequency. So here a higher frequency processor is executing the program faster under all other identical conditions on the same program. Because under all other identical conditions, a higher frequency implies a lower clock speed, and within a shorter time period, we are processing more instructions out.